we can record now. So, um, welcome everyone to the second day of this EUMETSAT webinar on MTG and EPS-SG. I am Srilekha Thoniparampil. I am managing the EPS-SG user preparation project here at EUMETSAT. And I'm organizing this webinar together with Stefan Bijinski, my colleague, who is the MTG user preparation manager. And this webinar is specifically for the manufacturer community, so both hardware and software manufacturers who are supporting EUMETSAT's member states in the reception of the data, in the processing of the data that is coming from both MTG and EPS-SG missions. So in this webinar, we will be using Slido. This is an app for asking questions. So you just, for those who are not familiar with Slido, you can go to www.slido.com and then type in a code MTG/EPS/SG, and then you will have an option to ask questions. I have posted this in the chat, the Slido code. So please use that for asking questions. And if you have any technical issues, just use the chat, Zoom chat for that. And one more thing, we will make available the recording of this webinar, the recording, the slides, and all the questions and answers that will be asked during this session. So with that, I share my screen with a short introduction to, sorry. Just a moment. Okay, share. Can you see my screen, Regina? Can you see the screen in full screen mode? Maybe?
Not yet.
Okay, now.
Now.
Okay, thank you. So this slide, for those who were present yesterday, you might have seen this slide presented by my colleague Adam Eddy. This is showing the full fleet of EUMETSAT's geostationary, the next generation polar and geostationary satellites. So yesterday's presentation was focused on MTGI, which was launched about a year ago. And today's presentation will be focusing on the METOP-SGA and METOP-SGB, which is EUMETSAT's next generation polar satellites. So EUMETSAT Polar System second generation. In its full configuration, this will be two satellites, METOP-SGA and METOP-SGB. And as you know, this is a follow-on of the METOP satellite. So it will be on the same orbit as METOP, so sun-synchronous orbit at about 800 kilometers altitude, and the local equator crossing time of 9:30, thus fulfilling our commitment to the mid-morning orbit. And next slide, I show a small overview of this satellite. This is a video. So you see the two satellites, but this is symbolic. They won't be as close as you see here. So this is the first satellite, EPS-SGA, METOP-SGA satellite, which is having a fleet of many sensors that are also follow-on from METOP satellites, but with much enhanced spectral, geometric, and radiometric performances. You also have a new mission, the 3MI. The second satellite is following what you see behind with here. And this is a microwave imaging satellite. So to say the first one has both imagers and sounders. So here also you have the heritage instruments, the radio occultation, which is on both satellites, and the scatterometer, which is a follow-on of ASCAT. But you also have new instruments, a microwave imager and the ice cloud imager, which is a sub-millimeter sensor, the first of its kind in space. So that's just a short introduction to today's presentation. So over to today's presentations, our focus will be on the EPS-SG local mission. And I invite the first speaker, Michaela Sunda, who is the lead of the EUMETSAT EPS-SG instrument functional chain team. She will introduce the EPS-SG local mission. It's the first presentation. Over to you, Michaela. Yes, you are good to go. I think you're muted, but you're okay. It's not in full screen.
Should be fine now?
No,
Not
now
in
it
full
is not
screen.
in full screen now.
Working now?
Yes, in full
Okay,
screen,
good.
good to go.
Yeah.
Good luck. Thank you.
So, thank you, Shrika. Good afternoon, everyone. My name is Michela Sunda. I'm working at EUMETSAT in the EPS-SG system team, together with Davide Castellazzi, Andrea Cini, and Carlos Mas. And I'm responsible to follow up the development of the level 0 and level R local processor software packages for the EPS-SG local mission. I will start today with this first presentation about EPS-SG local mission introduction. So I will introduce the EPS-SG local mission. I will give an overview of the local mission, which are the key elements in the chain at the local user station. I will also introduce the main requirements driving the implementation of the local mission and the local processing software packages that basically are used to transform the EPS-SG raw data in level 0 and level 1 NetCDF products. I will also introduce the interfaces and the software packages for the local mission in a second presentation. So this one will mainly focus in giving an introduction of the local mission, context, the key elements of the chain, and the main system requirements for the local mission. So EPS-SG mission is implementing 3 missions: local, global, and regional. Global mission is for generating and distributing products generated with over the globe. The data is collected in half orbit segments using Svalbard and McMurdo ground stations, and is processed and disseminated at EUMETSAT in Darmstadt. The regional mission is again for generating and distributing products over the regional area of interest, that is Europe and North Atlantic. And we will see in a second slide with improved timeless performance, dissemination performance. Then we have the local mission, where the data is distributed to user stations via direct broadcast, and the data is collected in smaller segments and processed directly by the local users. Here we have one slide with an overview of the EPS-SG instruments, missions. Can be on METOP-SG-A satellite or METOP-SG-B satellite, or both of them, like in the case of the radio occultation mission. So we have METIMAGE, visible infrared imaging mission. We have infrared atmospheric sound emission, YASIN-G, on satellite A, both of them. We have microwave sound emission, MWS, again on satellite A. And we have also multi-viewing, multi-channel, multipolarization image mission, 3MI, on Sat A, together with Sentinel-5 OVNS mission, and ARO, radio occultation mission. On Sat B, on METOP-SG-B satellite, we have the microwave imaging mission, MWI, ice cloud imaging mission, ICI. We have scatterometry mission, SCA, and we have radio occultation as for METOP-SG-A, and we have also the advanced data collection system mission, ADCS. So this just to give a quick overview of the EPS-SG missions. So I move to the next slide. So now we focus on the local mission, one of the 3 implemented in EPS-SG. So which are the key points of the local mission? All data, all instrument data will be broadcast in real time by the satellites to the receiving stations in visibility of the satellite. And this is the concept of direct broadcast that EPS-SG is implementing. Transmission will be in X-band. This is different from METOP first generation, where the transmission was in L-band. And so reception of data is via 3-meter antenna. Local mission is available only for the instantaneous field of view of the satellite individual instruments. The local data arrives in real time within 10 seconds of sensing time, and this make this mission useful for nowcasting and short-range forecasting applications. In order to receive this data and process this data, local user will need suitable equipped user stations. That means with level 0 and level 1 software installed in a proper environment. Which are the main differences between local mission and global mission? So, downlink of mission data, as I said, from the spacecraft will only consist in instantaneous near real-time data. There is no concept of store mission data. So the local user will not have access to past and future data, but only for the instantaneous field of view. What the satellite is acquiring this time is what the local user is downloading. The local mission products are directly processed by the local user at the local user station. And so the timeliness of this product is significantly improved, especially with respect to the global mission. The concept of direct broadcast we have already explained. So the data is acquired directly at the local station owned by the local user. Level 0 and level 1 products are processed at the local user station and are unique to the users and depends on the specific configuration of the science data processing environment set up at the local user station. Of course, local mission has limited coverage in sensing time. Global mission basically is data acquired over the full globe. Local mission is only data acquired during the pass at the local user station. To process level 0 and level 1 product, local user will need auxiliary data. These auxiliary data are provided by external entities like ECMWF and will be under user responsibility. This data is not disseminated by EUMETSAT. EUMETSAT will provide to the local user auxiliary data that is generated at EUMETSAT, like for the level 0 processing, the predicted orbit file. So whatever can be accessed outside EUMETSAT is under local user responsibility to retrieve it. Otherwise, EUMETSAT will disseminate it because EUMETSAT is the source of this auxiliary data. As I said, like for the predicted orbit file. So, which are the main requirements that drives basically the implementation of the local mission? We have three main requirements. The first one defining the scope of the software used at the local station to produce level 0 and level 1 products. So it's about availability of a portable software, including source code, and made this available to the local user. This software will cover, as I said, the level 0. For the level 1, will cover YASI-NG level 1C product, MWS level 1B, METIMAGE level 1B, SCAL level 1B, MWI level 1B, and ICI level 1B product generation. And for level 2, will cover the VII level 2 Cloud Mask product generation. So local mission and local processing software packages will cover this subset of instrument processing chains. The second requirement is about data latency. So basically timelines performance for the local mission. and we have basically a range from 10 minutes to 30 minutes from sensing time. And then we have a last requirement that is about the accuracy of the products. So basically the local products generated at the local user stations needs to be in agreement with the products generated by the global mission within a tolerance of not greater than 10%. This requirement covers both radiometric, spectral, and geometric requirements. So these are the three main requirements that are driving the local mission implementation and the implementation of the level 0 and level 1 local processor software packages. Next slide is about near real-time dissemination requirements. On the top left, you have the requirements we have in the system requirement document. So for the level 1 products at global level, we have 70 minutes from sensing. For regional level 1, we have 30 minutes from sensing. And for level 2, we have 80 minutes from sensing, except for Sentinel-5, where we have 165 minutes from sensing. And then we have, for the regional level 2 products, 40 minutes from sensing. At the top right, I have also included again the runtime performances and the data latency for the local mission. So basically, same information I provided in the previous slide, but now with a translation of the data latency in runtime performance for the local processor software. So for example, MetImage will need to produce level 2 cloud mask products within 10 minutes from sensing. If we compare regional mission with local mission, there is no the dissemination timeliness is comparable. We don't have a big deviation. The big deviation is between the global and the local. So within the area of interest, that is Europe and North Atlantic area, the gain processing data with the local mission is limited with respect to the because we have the regional mission. But when we go outside the area of interest, of course, the local mission will become very important because the delta with the global mission will become relevant. I move now to, again, I focus now to the EPS-SG local processing software. So here is a diagram showing the key elements of the chain at the local user station. So we have broadcast will be in X band, as I said before. At the local station, we have the receiving antenna, we have the demodulator and the front-end processor, and then we have the local level 0 processor, and in sequence after the level 1 local processors. The level 1 products generated within the local level 1 processor are further processed by the local user with their software. It is not shown in this slide. This slide just stop the local level 1 processor, that is the software provided by NWP SAF to the local user, but it's clear that after this stage, there will be other software installed at the local user station deriving level 2 and level 3 products or specification is owned by the local user. So the interface between the key elements, especially between the local processor software, is file-based, as shown in the diagram. And this will be presented in further details in my second presentation. I give now an overview of the local processing software. So level 0 local processor is being developed under EUMETSAT responsibility and will allow to generate level 0 products in netcdf format starting from vCDUS files. Level 1 local processor for MWS, MetImage, MWI-ICI, and SCA. Level 1 is developed again under EUMETSAT responsibility and will allow to generate basically level 1B products in NetCDF format, starting from the level 0 products generated by the level 0 local processor. The exception is EPS-SG level 1C local processor. This one is being developed under CNES responsibility and will allow to generate EPS-SG level 1C products, again in SCDF format, using as input the level 0 products, but also the VII level 1B and the VII level 2 cloud mask. EUMETSAT will deliver all the software packages to NWP SAF, one software package per instrument at launch minus 1 year. And the software will be made available to the local user by NWP SAF, and there will be a dedicated presentation later today. The Cloud Mask Level 2 processor is not developed under EUMETSAT responsibility, is a software developed under NWC SAF responsibility, and allows to generate level 2 Cloud Mask products, starting from the MetImage level 1B products in NetCDF format. And the software is already available from NWC SAF. That's all for this first presentation, the introduction of the EPS-SG mission. And if I'm Shrika, I move to the second.
Okay, I think we will ask if anyone has any questions.
Okay, yeah,
And
right.
let me just check. So I welcome all of you. If you have any questions, first of all, thank you, Michaela, for the presentation. So please post your questions to Slido. Let me just check if there are any questions so far. Okay, there's one question, so I think I will present it. Michaela, just a minute. So I'm stopping your presentation.
Yeah, done. It's done.
And I bring this one. So so can you see the question, Michaela?
Yes,
I will read.
yes.
So it's asking if there is a regional and local mission for Sentinel-5. I think in your presentation you mentioned Sentinel-5, there's no local mission, but you can answer. This is
there is no, for Sentinel-5 we have only global mission implemented as part of EPS-SG.
Okay, thank you. So I don't see any questions now, but Michaela will be doing a second presentation and she will be available to answer any questions if you have related to both presentations. So if you have, if you need time to still ask questions, she's available. So Michaela, in that case, I think you should move to your next presentation.
Visible now, Shrika?
Yes, it is visible now in full screen. Then let me mute myself. Thank you.
Okay, so this is a second presentation about the status of development for the level 0 and level 1 local processor. This presentation is given together with my colleagues Andrea Cini and Carlo Mas. Just recap of what has been already presented. So for the EPS-SG local processing software, we have the following set of processor provided to NWP SAF, level 0 local processor, MWS level 1B local processor, VII MetImage level 1B local processor, MWI ICI and SCA that are SAT-B instruments on METOP-SG B satellite. And then we have EPS-SG level 1C local processor that is developed under CNES responsibility and will be provided to NWP SAF via EUMETSAT. So this slide gives an overview of the processing chain at the local station for SAT-A. This diagram includes all the processor. Of course, the configuration at the local user station can be different with only a subset of these processors. Here we are just showing the full chain. The most complex one is the YASI-NG. So the YASI-NG level 1C local software will need MetImage level 1 and Cloud Mask level 2 products as input. So the full processing chain will involve 4 processors in sequence. Again, this diagram is not showing the level 2 local user processor software that will be after this chain, triggered after this chain, and stops just at the local processor software packages provided by EUMETSAT. So again, data will be broadcasted in X band, receiving antenna, demodulator, and front-end processor are the first element of the chain. And then we have the level 0, level 1 local processor software. And in case of MetImage, we have also a level 2 local processor software. Auxiliary data, if generated by EUMETSAT, will be disseminated by EUMETSAT dissemination mechanism. And if auxiliary data can be retrieved outside, are generated outside EUMETSAT, this has to be retrieved directly by the local users via the external entity. This is for SAT A. We have a similar one for SAT B. It's simpler. We have only level 0 processor in this case, coupled with MWI level 1 local processor software, or with ICI, or with scatterometer level 1 local processor software. So in this diagram for SAT B, the boxes in gray are basically procured by EUMETSAT. Level 0, MWI level 1, ICI, and SCA level 1 are all software procured by EUMETSAT. The boxes in white, the procurement is under local user responsibility. And for the previous one, we have only also the VII level 2 Cloud Mask local processor software that is developed under NWC SAF responsibility. So whatever is under white color is basically under the local user responsibility to procure it. Okay, starting from the demodulator and front-end processor. In the schema is the box and in yellow. It is basically procure under local user responsibility. Again, will allow to basically generate virtual channel data units, VCDU files, and to interface the level 0 local processor. We have 3 main output to be generated via the DFAP. VCDUs already demultiplex for different VCIDs and quality checked. This means no idle or duplicated frames included. Or we have the possibility to trigger the level 0 local processor with VCDUs already demultiplex for different VCIDs, but not quality checked, so idle or duplicated frames are included. The level 0 local processor will remove them. And we have also the possibility to trigger the level 0 local processor with annotated VCDUs. We call them eVCDUs, which are VCDUs with a variable number of bytes of annotation that can be also managed by the level 0 local processor, which will remove them. The interfaces are compliant, both CADUs and VCDUs are compliant to the EPS-SG space to ground ICD. We have made available in in internet. Here you find the link, the EPS-SG direct data broadcast radio frequency space to ground interface control document. Well, all these interfaces are described. So these are the three categories of VCDUs which can trigger the level 0 local processor to create level 0 NetCDF products. The procurement and the configuration of the local user station up to the DFAP is under local user responsibility. Then we have the EPS-SG level 0 local processor software. This will allow to go from VCDUs to level 0 products in NetCDF format. The VCDUs generated by the DFAP are files. Again, the interface is file-based for the level 0 local processor, both in input and output. And the VCDUs are basically one file for each VCID downlink by the METOP-SG satellite. And this has to be made available in a folder location accessible by the level 0 local processor. As I said before, auxiliary data needed by the level 0 processor are basically two: the IRS bulletin and the predicted orbit file. The first one is accessible outside EUMETSAT, is generated outside EUMETSAT and need to be retrieved by the local user. The predicted orbit file is generated by the flight dynamics facility here at EUMETSAT and will be made available by EUMETSAT via the standard dissemination mechanism. So all the output files generated by the level 0 local processor need to be stored in a file system, and these need to be made available to the level 1 software for ingestion. Again, the interface in terms of VCDUs are described in the space to ground ICD that we made available on internet. And the output of the level 0 product is described in the EPS-SG level 0 product format specification. It is a document, EUMETSAT document, and will be published soon, next month. The level 0 local processor can be executed as a standalone component by command line, where all the arguments are passed via command line and all the input data is available in a file system. Again, the inputs could be VCDU files, already demultiplexed and quality checked, or already demultiplexed but not quality checked, and can be also in forms of annotated VCDUs. The level 0 local processor has also another capability, can be triggered with a stream of CCSDS packet, instrument source packets, one binary file per instrument. And needs as input two auxiliary files, predicted orbit file and IRS bulletin A. And the products are again level 0 products in NetCDF format, one for each instrument. And all of that is specified in the level 0 product format specification. The content of the level 0 products is defined via a configurable mapping between VCID and APIs and product types. And this mapping basically determines which packets go in which product type. The output of the level 0 local processor software are shown in this table. We have one level 0 product for YASI, for ICI, MWI, MWS, SCA, and METIMAGE. And we have also the level 0 product associated with NAVAT, data, navigation and attitude data that is an input to the level 1 local processor. So the level 0 local processor will allow to generate all these level 0 products, one product per instrument, including NAVAT data. Moving now to the level 1 local processing software. The interfaces of these softwares are again file-based, so in input will accept level 0 products in netcdf format available in a file system. Need in input also auxiliary data, usually instrument characterization calibration databases. This data will be made available by EUMETSAT via the standard dissemination mechanism. These files again need to be made available via file system to the level 1 processors. Level 2 Cloud Mask is a mandatory input for EASY-NG level 1C that anyway can be run also without VII information at both level 1B and level 2, but with a graded performance. The generated level 1 products will be made available in a file system, and these will be further processed with the local users' processing facilities. Like for the level 0 local processor, the software can be executed as a standalone component by command line with all the input data available in a file system. The local processor software will be made available by NWP-SAF to the local user in form of one package for each instrument and level of processing, including source code for the organization that does not permit installation of precompiled software. It's important here to say that in case of EASY-NG processing chain, EUMETSAT will not deliver a single software package, including METIMAGE and EASY-NG chain, but will deliver one software package for each processor. So one for level 1B, METIMAGE level 1B, one software from NWC-SAF to generate level 2 Cloud Mask products, and one software package for EASY-NG level 1C. And it will be under NWP staff responsibility to provide help desk to the local users and to establish the agreements with each user. Here we have a table, again, with a summary of EUMETSAT level 1B product format specification. So the products generated by the level 1 processor are described in the EUMETSAT level 1B product format specifications, and these are already available in internet. And on the right of the table, you have the link to the EUMETSAT webpage when these documents can be retrieved, downloaded. In terms of development status, for the level 0 local processor, we have already a first version available at EUMETSAT. It was accepted in May 2022, but it's not the final one because it's based on instrument specification from the instrument CDRs. We have just now accepted a second and final version. This is the one to be used for commissioning. And this includes also test data, VCDUs in input and output data for the level 0 local processor. This will be published in internet in December this year. Together with the instrument, the interface control document of the level 0 local processor and the level 0 product format specification, as I said before. For the level 1, for MWS level 1, the software is under development. The design review of this software was conducted successfully in February 2023, and the software is expected to be delivered to EUMETSAT by end of November. A second version of MWS Level 1 will be made available to NWP staff in Q2 2024, and this will be the launch version, because we need to implement some minor changes from the instrument on ground characterization and calibration campaign, including the new ICCDB. For the MetImage Level 1 local processor, we are developing the first version of the software, and this one is expected to be delivered to EUMETSAT in December 2023. But this version is not implementing the right configuration of the Straylight algorithm, so we will need a second version to correct with the right algorithm to correct the Straylight format image, and this will be made available to NWP staff in Q3 2024. For YASI-NG, again, is developed under CNES responsibility. The design review was successfully conducted in March 2023, and we will have for this software one single version expected to be delivered to EUMETSAT in June 2024. For the SAT-B level 1 local processor, these are being developed. Design review was conducted in July 2023, and the software is expected to be delivered to EUMETSAT in February 2024. There is a typo in the slide. I will fix later. And the second and final version will become available in Q4 2024. We made available also in internet a first version of the EPS-SG local mission chain hosting environment, where we are described essentially the hardware needed to host the level 0 and the level 1 processors. I don't go now in details, because these details will be given later by Fabien in the NWP staff presentation. This document is available in internet, and you can find in the slide the web page from to use to download it. So I give now the floor to my colleague Andrea Cini, that will introduce the EPS-SG data volumes and data rates.
Can you click for me?
Yes,
Okay.
yes, sure.
So hello, my name is Andrea Cini. I'm working in the system team of EPS-SG, and I'm going to present you some figures about the involved data volume for the local mission of EPS-SG. So in general, EPS-SG has been advertised as a mission giving an improvement with respect to the previous one, so with respect to EPS, an improvement as big as 20 times 20 times more data. This means that this mission, also because it has been, it is the follow-on of the previous one, of the first one, is expected to generate much more data with his instruments, achieving better resolution, better sampling frequency, and in general, a global enhancement of the quality of data produced, data and products. This is reflected obviously in a largely increased data volume, both in terms of data generated on board satellites, and in terms of volume of product generated. This magic number of 20 can be easily seen when comparing the data rate of the space-to-ground link supporting the local mission. We have 80 megabit per second for EPS-SG-A. We had 3.5 megabit per second for EPS. So this gives the measure and the feeling of how much more data this mission is generating. In this case, the ratio is indeed a bit more than 20. This is because the instruments on EPS-SG are more technologically newer, more modern, and so they are producing much more data when compared to the first generation. In the next slide, we can see an overview of the data rate of the single instruments involved in the local mission. The first difference you can see is that on EPS first generation, data rate were given in kilobit per second. Here we have megabit per second. And in general, we have some instruments speeding up to 25 megabit per second, like MetImage, while the maximum on the first generation was 1.5 megabit per second with YASI. So this gives an idea of how much more data is involved in acquiring and processing data of the second generation. We can see in the second slide, in the following slide, this is a summary of how much data a single pass of the local mission can produce on ground compared with the same amount of data generated by the first generation. If you look at the green cell, you see that the second generation produces roughly 2.5 gigabytes of level 0 data per each pass acquired on ground if the local station is a full-featured local station. So it means a local station acquiring all the possible instruments. And this value, when compared with the same value of the first generation, is greatly increased. We had before 200 megabit per pass. Consider that a user station at the latitude of Darmstadt, so in the middle of Europe, can acquire up to 5 passes per day. So these are the values relative to a single pass. So they must be multiplied for the number of passes planned to be acquired in order to have an idea of how much data the local station must manage. In addition, you can also see that in the blue cell, this is the amount of data, the data volume of all the products generated by the local station. You see, on the second generation, we have 2 satellites, strongly unbalanced in their production, because we have the satellite A, which is generating roughly 1.5 giga per pass of products, while the satellite B is generating only 320 megabytes, which is almost directly comparable with the first generation. So the ratio here is not 20, but it is, however, a big increase of data, mainly in terms of data volume of generated product, also for the local station. And on this topic, that's all on my side.
Yes, we have just 2 slides more. These are basically tables summarizing the dissemination baseline for EPS-SG, so which products will be disseminated by EUMETSAT in near real time via EUMETSAT satellite or EUMETSAT terrestrial. We have baseline for SAT-A global and regional missions. The data will be disseminated in NetCDF4 format. For some of the instruments and products, there will be also dissemination in BAF format. It is just to give an overview of the dissemination that will be implemented by EUMETSAT in operations. We will have also a non-near real-time dissemination via the archive data store, UMARF at EUMETSAT, basically the same content of near real-time dissemination. And for SAT-B, there is a similar situation, so product will be disseminated via EUMETSAT satellite terrestrial, some of them in NetCDF format only, like MWICI level 2 products, all the others in both format, NetCDF and buffer format, and both of them will be available for retrieval also in non-near real time via data store or UMARF, EUMETSAT archive. So that concludes our presentation. Ready for any question? Thank you.
Yeah, there are a few questions, so I will bring up the slide. Thank you very much, Michela and Andrea. Let me present in full screen. Share screen. So, can you see the questions? So okay, a minute. Okay, will the format for auxiliary data input for level 0 be provided, or will this be taken care of by the level 0 software?
The format of the auxiliary data can be provided via an official document. We have the generic auxiliary data specification, where the format of this file is well described and can be made available.
Okay.
The level 0 processor will be able to read data in this format, in the format described in these documents.
Okay, thank you, Michela. I'll move to the next question. You described a receiving antenna of 3 meters. Does this apply the local, I think, does this apply for the local and global mission?
No, this applies to the local mission. The global mission is K-band, so the antenna is much larger.
Okay, thank you. Next question. To clarify, for ERC-NG level 1 processing, one needs 5 softwares: VII level 0, level 1, and Cloud Mask, ERC-NG level 0 and level 1.
Yes, correct. If not run integrated mode without MetImage, yes, it's the most complex chain. Yes.
Okay, good. Thank you. So your message is being followed by the attendees. That's good. Thank you. Next question. Will the VZDU payload specification will be published so manufacturers can develop their own level 0, level 1 processing software if decided?
VCDU documentation, I think, is already published. We have provided in one of the slides the reference to the space to ground ICD. But these files need to be processed with the level 0 and level 1 processing software delivered by EUMETSAT.
Okay. Fabian commented that I cannot be heard very well. Is it better? Or?
Yes, yes.
Okay, thank you. So, Michela, you have answered all the questions, and I think, oh yes, he says it's better now. Okay, so what we do next? So let me just stop share. I think we decided to go for a break of 5 minutes. So we meet in 5 minutes. Is that okay for everyone? So we meet at 15 CET.
Yes, fine.
And for the participants, we also have a poll, or rather a survey on Slido to know how your feedback on today's session. I will post a link to that poll, and it will help us perform better for the next webinars if you post in your comments about this one. Thank you very much. I'll post that soon. And then we meet in 5 minutes. Thank you. This is a small break. Thank you. We move to our next presentation by Fabian Caminati. He is the numerical weather prediction so satellite application facility project manager, and he works at the UK Met Office. Thank you, Fabian, for agreeing to present today. And I give the floor to you.
Thank you and welcome everyone. So this set of slides will show you an approximate timeline of what the NWP-SAF will deliver, since Michela gave already many details on the packages, but I will come back to it. So first, what is NWP-SAF? In case you're not familiar with it, the satellite application facility for numerical weather prediction is one of EUMETSAT 8 SAFs, which is dedicated to help Met services across Europe, but also across the world, to maximize their benefit from satellite data for their NWP applications. And we have activities gravitating around the development, distribution, and maintenance of software, the monitoring of the operational satellite network, and everything related to user support, outreach, and training activities. A brief overview of our portfolio. So we have the software, some pre-processing packages, the AAPP, so that's level 1 pre-processing, for AAPP for sounders, so YASI or any actual EPS instrument sounders. Then we have the IRSPP that has already been released in advance of the instrument launch for MTG IRS, a preprocessor for the microwave imager, MWIPP. We will soon have the EPS-SG L1 preprocessor for level 0 to level 1 reception. And then we have everything else related to NWP applications, such as the fast radiative transfer model, RTTOF, one-dimensional variational assimilation tool for standalone application, Radiant Simulator, which is a kind of wrapper for RTTOF, and the cloud aerosol and trace gas detection software. As I said, we have some monitoring services, near real-time and in-depth quality assessment investigations, and everything related to outreach and training, such as training courses in partnership with the CMWF and scientific workshop. Is a summarized timeline of what is already available and what's coming in the coming months and years. So it goes from Jan 2023 to early 2025 with METOP-SG A1 planned for early 2025. So in terms of preprocessor, what we already have, AAPP, IRSPP, and WIPP, in version 8.1 and 1 are already available. And for your downstream application, the future version will be made available soon after MTG launch for IAPP, a bit before for IRSPP. But what might be of greater interest to you today is the EPS-SG level 1 preprocessor. So we will release a test report ahead of launch around July 2024 and a beta version 3 months before launch, 6 months before launch. And then again, the full version after launch, once we will be able to test with the software with real data. More detail on that in the coming slides. Again, downstream application, if you are a user, RTTOF, RADSIM, and WANDIVAR will be updated early mid-2024. And a minor version, major version for RTTOF and RADSIM, and minor version for WANDIVAR, as well for the cloud detection software. So focusing now on the EPS-SG local processor, the version 1, the one dedicated to SAT A1. So again, planning for launch Q1 2025 if nothing change by then. The NWPSAF has 4 main deliverables. So 2 deliverables are pre-launch and 2 deliverables are post-launch. So after EUMETSAT delivers the software to us, we will make available to the user end-to-end verification report detailing the ins and outs of the software, and that will be made available 6 months after we receive the software, which is 6 months before launch. And then at software delivery plus 9 months, so 3 months before launch, we will have the release of the beta version. Then after launch, 6 months after launch, we'll release a new report, again, end-to-end verification, but based on actual real post-launch data. And at the same time, roughly at the same time, the full version of the V1 software will be released and documented. As swap slide, you'll see that's exactly the same slide except for the name of the software, that's the version 2, and for the date, because it's regarding MTOP SGB1 due to for Q4 2025. The deliverables are exactly the same. The date does not change because they are related to when EUMETSAT releases software to us and when the satellite is launched. So again, end-to-end verification report 6 months before launch, beta version 3 months before launch, new report with real data after launch, and full final version of the software, so 6 months after launch. So in summary, Michaela said already a lot about that, but just summarize here in the slide. The satellite are sending to the user raw data, and if you want to make use of them, you'll need to have calibrated and geolocated data converted to level 1 for most applications. And that is done through that software that EUMETSAT is procuring. What we know, what we expect, is that there will be a separate level 1 package for each instrument. There will also be a level 0 package, transforming raw VCDU to level 0. The source code will be provided, but NWPSAF is also planning to create executable for users who prefer pre-built software. The code itself, will be a mixture of Fortran and C++, and run on Linux 64-bit platform, and that's the platform on which the NWPSAF will test it. It is probably possible to run the softwares on different platforms, but we won't guarantee it because it won't be tested, at least not by us. And we also expect that user will be able to use GNU or Intel compiler, given what we know so far. Navigation calculation, we've heard that from Michaela's slide, will use ESA-UO CFI software, which is a pre-built package, and all the details are available on the link here on the slide. In terms of input and output, it's file-based. Again, we've seen that before with a work order flow control, but the NWPSAF will look into automating the process via shell scripts, which will be delivered together with the software when the user download the package from the NWPSAF website. Level 1 products will, from the local mission then, will be compatible with equivalent EUMETSAT global product within the acceptable tolerance. And the final part here is just to stress again that EPS-SG provide 20 times more data than the previous generation. And if you want to stay in line with DBNet, for example, direct broadcast network from WMO requirements, which are between 20 and 30 minutes for sounders and 10 to 20 for imagers. You will probably need to be very careful with your hardware. So here's are the number of physical cores that you're going to need. So for MWS, you need 1 core, and then between 60 for VII as well. For CM BPS software from NWP-SAF that you need 1 core. For the level 1 local processor, you need 16. Scatterometer, you need 24. MWI 16, ICI 16 as well. And here you have a red flag on YASI, because if you want to carry on, just like with the YASI and GNME, if you want to carry on just as the previous version, YASI on METOP satellite, you will need 88 cores. So on the right-hand side of that slide, you have the tables showing the number of cores and the max load usage for a 12-minute pass of data. So to be within acceptance of DBNet requirements, 88 cores is the minimum you need. You have to have in place. And that's all for me. More information will come in the coming months on the NWP-SAF website. Sorry, you have the link here on the slide. And any question, please just let me know.
Thanks, Fabien.
And I'll stop sharing, otherwise I can't see the screen. Here we are.
Okay, thank you, Fabien. Thanks for the presentation. There are a couple of questions. I just present them in full screen and then share. I think that's how I can show it. Can you see the question?
Yes.
To clarify my earlier question, will specifications be published containing the data formats needed for manufacturers to develop VCDU to level 0, level 1 processing software? I think this is to Michaela, actually, Fabien. So maybe, Michaela, are you there?
Yes, I'm here.
Have you, I think this question was earlier asked similarly. I don't remember what was asked earlier, but I think it's clarifying the earlier question related to the publication of the formats for manufacturers to develop their own VCDU to level 0, level 1 processing software.
Yes, the specification of the algorithm, level 1 algorithm, will not be provided, and also the specification of the instrument source packet will not be provided, will not be published.
Mm-hmm. Okay. Thank you. So I'm marking this question as answered. And then I think this question is to Fabien. Delivery schedule, or maybe to both. Delivery schedule of level 0 software is not clear. Is this package delivered by NWP-SAF or EUMETSAT?
Michaela, you want to answer, or I'm going?
If we follow the same process of EPS, this software will be also made available web page together with this data and level 0 interface control document. But Fabian, as I said, if we follow the same process of METOP first generation.
Yes, it's meant to be seen. Maybe we can also make it available on the NWP-SAF website, so that we are not going to test that one, but I guess from a user perspective, it would be good to have all in one place. So there's no problem in making it available from the NWP-SAF website.
Okay, thanks. But the delivery schedule of level 0
yes.
is then, sorry, yeah.
Mm-hmm. So in terms of schedules, it depends. I think
for level 1, you said it is 6 months before launch?
Yes, well, it depends whether you're thinking about the delivery of the software to EUMETSAT or to the user.
To the user, I think this is to the
yes,
user,
the
I
question is
think.
probably to the user, and to the
Mm-hmm.
user, the NWP-SAF makes the beta package available 6 months after EUMETSAT delivered to us.
Okay. So
Sorry.
it is 6 months after EUMETSAT's delivery to NWP-SAF.
Exactly, yes.
But
I can't put a date on it because we don't have, we don't know exactly when we receive the software. But as soon as we receive it, 6 months later, it will be available.
But Michaela's presentation showed that the software will be delivered to NWP-SAF 1 year before launch. So this is that's why I mentioned, so 6 months before launch, you will receive the software, isn't it?
Yes,
because
yes, that's correct.
You will receive the software 6 months before launch. And then what is the timeline between you're receiving the software and delivering to users? That's maybe makes it clear that when you will be able to deliver the software. So is that 6 months or?
Yes, yes. Well, I can come back on my slides and
okay.
Okay.
So there's one more question, but we can come back to that. You can maybe share your slide.
Yes.
We have enough time, so we can be quite relaxed.
Okay. So the beta release is delivery of the software plus 9 months. So the user, from the user perspective, you will see the test report, assuming that those dates stay in place, the test report in July 2024, and the beta software in October 2024. And then the final software is 6 months after launch. So if we still are on Q1 2025, around June or July 2025, you will have the version 1 final software.
Okay.
I hope that answers your question.
Yeah. Okay. So now I bring back my slides. Share. Okay. I think this is clarified. If not, we can also write it a bit more clearly when we when we distribute the question and answers. But I think it is clear. We can maybe share the table. We are sharing the presentation, so this is fine. Okay, so then I go to the next question. What can you say about the expected amount of data? I think this is to Andrea or to Michela, your team.
Okay. Okay. I'm here. So about the expected amount of data, my presentation, I try to retrieve it.
Yeah. Please.
Just I would like to understand if there is some special information looked for, because so just a moment. I make the sharing.
Expected amount of data. So
okay, the expected amount of data is drafted in this slide. Expected amount of data, if it is produced data by a local station, you can see in this column on the left for SGA. Do you see the slide?
Yes.
Okay.
Yes.
You can see in the left part of this table, we have two macro rows, one for SGA and one for SGB, because the instruments providing local mission services of EPS-SG are spread over 2 satellites. So depending on which instrument the user is interested, he may need to acquire either one or the other satellite or both. The amount is basically the one highlighted in boldface in this table. split by level of products. And the two numbers in blue are the total. And these are numbers relevant for each single pass of the local mission. So this means that this number must be multiplied for the number of passes which are planned to be acquired every day. So these are basically the numbers. So the size of product generated by the local mission. And I don't know if this answers the question or if something more detailed is searched for.
I don't see any more questions actually, so maybe this is clarified, or we wait for a minute. But if you have any further questions, which came to you later, then please contact us via the EUMETSAT user help desk. I have posted the email address in the chat. It's ops@eumetsat.int, and we will get back to you with answers if they are not answered in this session, because I don't see any more questions here.
Okay.
Thank you, Andrea.
You're welcome.
And thank you, Fabienne, you too. And I think that's all we have today. Please also, like I said, post your feedback by clicking the link that I have posted again in the chat. And thank you for listening. And also thank you to all the speakers. If you can show your faces now for one more time, switch on your video. And I have to also mention the support of, first of all, the speakers from yesterday, Adam Eddy and Andrea Merener. Thank you very much for yesterday's session. And thank you to Michela Zunda, to Andrea Cini, Carlos Mas, and Davide Castellacci, and Fabian Caminati today. Thank you to all speakers. You can show your faces. And I should not forget to mention Regina Hoffenmeier, who supported with admin support yesterday and today. Thank you, Regina. Thanks, everyone. We finished maybe a bit earlier than we anticipated. Hi, Carlos. Bit earlier than we anticipated, but this is always good to finish early than later. Thanks, everyone. Thank you for your support. Thank you for attending. Thank you very much. Bye-bye.
Thank you very much. Bye.
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 Bye-bye.